So I'm going to talk about money as a service. And specifically, I'm interested in kind of discussing and sharing with you one of the really new ways in which the finance world is changing. We've heard about fintech, financial technology, and we have a lot of people building solutions. And those solutions are geared towards creating easy access to a lot of financial services, whether it is microfinance loans, whether it is the ability for you to send payments, money from one person to another. The technology is basically riding on, fintech largely rides on legacy financial infrastructure. But I am more interested in, let's go down to what exactly it is we do when we are talking about moving money. We're all very familiar with messaging. We send short messages on Twitter. We chat with our friends, family, co-workers, colleagues, using messaging platforms like WhatsApp. And even when it comes to the world of finance, it's not so different. It's still the same basic technology of messaging, sending messages from one endpoint to another endpoint. And we now live in a world where money has become digital. So we're all familiar with sending funds from a bank account to another bank account, and we just do that by, touching some buttons and entering some text on a mobile app. And what is really happening beneath that interface that we see is messages that are being constructed and sent from one end to another. And so we live in this world where messaging is really everything that we deal with. And when it comes to, the ability for you to send money from one end to another, we're all kind of familiar with some of these companies. Western Union, MoneyGram, Zoom, PayPal, Ria, UnionPay, MasterCard, Visa. Essentially, what these guys are doing is just finding a way to communicate an instruction or a message from the person who wants to send that message all the way to its intended recipient. And so we've had, a lot of these companies start using the internet to actually relay these messages. Now, if you know anything about the internet, you know that the internet is a very public, very insecure channel to send messages. But there's a reason why they still use the internet. And the reason is because of this technology called cryptography. And cryptography is essentially just how we can, there are essentially two parts to cryptography. One of them is I'm interested in hiding a message so that even though I am essentially broadcasting that message across this entire room, only the intended recipient can actually understand the message. And so the science that goes into how I can encode that message or how I can scramble that message so that only the intended recipient can receive that message is a part of cryptography. There's also another part of it that is not so popular but is also equally very important, and that has to do with a way by which I can create messages that I can guarantee will not be tampered with, and that I have a way of ensuring that the recipient can receive proof that that message came from me. And so we use what we call digital signatures to allow us to achieve that particular purpose. Now, all these systems are great. Western Union, InterSwitch, NIBS, they're all really great systems. We use them every day in our daily lives. A lot of people don't even know that they use those services sometimes are associated with these systems. And as technologists, we're always thinking things can be better. And what are some of those problems that we may say are related or these systems are kind of, have become part of these systems? One is that by virtue of how the technology itself is designed, it is centrally controlled. And so with central control, really, you don't have open access. If any of you here have actually tried to, play with some of these fintech APIs, you'll realize how very restricted you are on what you're allowed to do, right? And so these systems, naturally, because of how, closed they are, because of the fact that in order to ensure security, they have to lock down a lot of things, they are a victim of this particular set of problems. And so, again, like I said, as technologists, we're always thinking, is there a better way to do these things? And I'm pretty sure you guys have heard about this word called blockchain before. The blockchain is an invention that basically turns the entire model of how financial systems are built on its head. So everything I talked about, how they're centrally controlled, with blockchain systems, there is no central control. As a matter of fact, the control is decentralized, meaning that we find a way in which we don't necessarily need to go through trusted third parties or centralized authorities in order to be able to transact with that system or use that system. As a result, it's open for all. And that means that whatever kind of application you want to build, you are free to build those applications as you seem fit. As long as your application follows a set rules within the protocol, you're allowed to innovate within the bounds of the protocol. Blockchains are also radically transparent. So in a situation where you're dealing with, if we're going to look at banking systems, for example, it's important that the banks keep those ledgers or the records in the bank, they keep them secret. But with blockchains, everything is transparent, everything is visible. And the reason why we talk about transparency in blockchains is because for us to actually trust a system that goes against some of the tenets in financial information, we need some sort of transparency. I need to be able to see exactly what is going on. When we're talking about money, for example, it's important that we understand that if I am sending 50,000 naira to someone, that person has the ability to confirm that I actually do have that 50,000. And when we're talking about blockchain systems, it's not just that the two parties who are interested in transacting have the ability to trust the system that they're using to transact, but that every other person who is a participant in that system is also able to trust the system. Because I might be involved in a future transaction with a party that was involved in a transaction in the past. So I need some kind of trail to actually show that no foul play was involved. In 2008, some individual or group of individuals created or wrote a white paper for the first implementation of a blockchain. And that system that he created, or they created, or she created, now we don't know who the person is. The person just goes by an alias called Satoshi Nakamoto. They created the first open, peer-to-peer, decentralized payment system and digital currency. And that system is called Bitcoin. I heard about Bitcoin about 2 years later, about 3 years later after it came into fruition. And the first time I heard about it, being a technologist and someone who understands how databases work and everything, I initially dismissed it as being, no, it can't possibly work. And this was because, I kind of read an article about it and they were like, we're trying to play around with this system. We want to see if it will work. And I was like, I don't know how this thing works, but maybe it doesn't work as they claim it does work. But it took me another maybe 4 years dabbling with the technology, reading a little bit more about it, to eventually come to understand, oh, this stuff actually does work. It's open and it actually does work. Like, anyone can participate on the network. You don't need you don't need to fulfill any strenuous requirement for you to actually become part of the system. And so it really piqued my interest, and I started to delve into it a little more and a little more and a little more. And then when I started to discover some of the advanced features, which is kind of what my talk is based on, it even blew my mind even more. Because for the first time, you could actually create money that was programmable. We're here talking about Python, we're all talking about programming and our love for programming. And as a programmer, one of the ways in which your eyes actually start to glaze over is when you realize the kinds of things that you can achieve just with a platform like this. And so I'm going to talk about, how this system can be used to create new financial applications that work on their own without any need for someone to create stringent rules that need to be enforced by humans. Before we talk about that, we need to understand some things about how Bitcoin works. And at the base of Bitcoin are what we call transactions. A transaction naturally is just the ability for someone to send funds from one person to another. So if I create a transaction and I want my account debited with a certain amount of funds, and the recipient I'm paying, I want that person to be credited, then basically all I have to do is create a message. I create a message specifying those instructions. And then, remember when I talked about digital signatures? It's important in this system because the only way we can know who exactly is doing this transaction is to inspect the signature. And so whenever you take a check, for example, to the bank, they always require that before they honor the check, they need to see a signature. And it's not just sufficient that there is a signature, but the signature has to be correct. So they will look up in their systems and check, does this signature match with the signature we know belongs to the owner of this account? And if the answer is yes, then the check is honored. The same thing too applies, except that we're not dealing with physical signatures here, we're dealing with digital signatures. So remember when I said that you can program some of these things? It turns out that you can actually create conditions. So in that transaction, for example, my inputs would be 3 109 notes, and then my outputs, I'll have two outputs. One output would be the 250 naira that I want to pay, and then the change output will be the 50 naira coming back to me. Now, if you have that mental model about how we deal with cash transactions, then it's easier for you to understand how typical Bitcoin transactions work. You don't necessarily need two outputs. You can have a variable number of inputs and a variable number of outputs. So this is what a typical Bitcoin transaction looks like. I want you guys to actually look at this picture because it's going to be important in me explaining some of the concepts that I'm going to go into. Typically, every transaction has a transaction ID. And that ID represents a unique identifier for that transaction. That is to be expected, right? You want to be able to differentiate one transaction from another. Now, that transaction ID has to be unique because it doesn't matter if I am paying the same person multiple times. So despite the fact that I paid you yesterday, if I'm paying you today and I'm still sending funds to the same account, it should carry a different identifier. And so the identifier is very, very important. Bitcoin transaction IDs are actually a hash And when we talk about going back to to cryptography, I talked about things like being able to encrypt information or being able to create digital signatures. One of the primitives or one of the primitive functions in cryptography is the ability for you to take any size input and create a fixed size output that is unique. So if I have, Chinua Achebe's Things Fall Apart, I have the entire text of that book, and I pass it through a hash function, I would get something that looks like this. This very bold text, the very first line, after transaction, 7957835FE64, that represents a hash. And so what a hashing function does is to take any variable length input and create a fixed length unique output. It has to be unique. It's unique because even if I changed the word they, that's THEY, in the entire corpus of text in Chinua Achebe's work, and I change it to that THAT, the entire hash will be different. So it's a way for us to actually uniquely represent a body of text. And so every Bitcoin transaction has this unique identifier, which is essentially a hash of that transaction. So remember when I talked about inputs and outputs? Well, we have 3 transactions here. The first transaction has 1 input and 1 output. And typically, every Bitcoin transaction has an input, and that input references outputs from a previous transaction. Okay, maybe I'm getting you a little confused here. Remember when I said in a blockchain system, everything has to be transparent and everything has to be auditable. There should be no forgery or any fraud from anywhere. That means when you're creating a transaction and you're trying to pay someone, you can't pay that someone from thin air. That payment must have come from a payment that you received initially. And so the way we reference this is by referencing previous outputs in a transaction. So the second transaction here has 2 outputs and 1 input, and the same with the third. Now, usually what you do is, in referencing a previous transaction, you only just quote the hash and then something called the index. So the index starts from 0. We're all kind of familiar with Python arrays where we all have 0 indexed, where they're all 0 indexed. The same thing also applies with so many things actually that are computer science related or computer related. And so typically what you do is you quote the transaction ID that you're using in that particular input and then the index. If you look at this second transaction, we have 2 outputs. One goes to Bob's address and another goes to Alice's address. Now that first one, if we were referencing that, we would say transaction 0627 blah blah blah, index number 0. And that would be the output for Bob's address. Right? So let's move on to the next slide. So this is typically what I was just explaining. Every transaction references previous transactions and creates new outputs that can then be referenced in future transactions. And typically, when you have constructed such a transaction, you need to sign. And the signature basically is just a way for you to prove that you have fulfilled the conditions for spending that output. Now, I know I'm using words like output, inputs, and everything. It's important that we use those words because if you're going to study this topic in depth, you will come across these words all the time. So I want to talk about the Bitcoin scripting system, which is, for me, actually the really, really, really interesting part about creating Bitcoin transactions. And then I would have a demo where I would actually show you guys a couple of examples on how we can create some really, really interesting kinds of transactions. The Bitcoin scripting system is primitive. It's not a very, very complicated kind of scripting system, and it is done purposefully because really when you're talking about, I just want to create a financial transaction, there are not that many things you really want or you want to be able to do. For example, why would you need loops if you just want to pay someone? Why would you need, say, conditional statements? There are some kind of conditional statements that will make sense, but you wouldn't use something like a while condition or a until kind of condition. And so it's intentionally kept primitive. And one of the things you would know about scripting systems that are kind of primitive is that they are not Turing complete. Okay, and so what that means is that there are a limited number of things that you can do with it. Now, the reason why the Bitcoin scripting system is built in such a way that it is crippled, if we can use that word, is because security becomes a major concern. If I cannot, so in computer science, there's this particular concept called the halting problem. And the halting problem is all about, can I really tell just by looking at some code that this program is going to end? Well, those of us who have written Python programs before or have programmed for a number of years, we know that there's this condition called an infinite loop, where your program just keeps running and running and running and running and running, and it doesn't seem to have an end because the condition for it to end has not been triggered. And so, if we were dealing with something like that, in a scripting system, and we don't have certain assurances that the program will come to an end, we could essentially execute a denial of service attack. And so the Bitcoin scripting system is crippled in such a way that it avoids this kind of problems. The other very important thing to note about the scripting system is that it is stack-based. And in the next slide, you would see what that actually means. Okay, now we're getting into the meat of what I'm here to talk about. Every Bitcoin transaction has a locking script, and it also has an unlocking script. The unlocking script basically just tells you that this is me proving that I can unlock this transaction. And unless the unlocking script matches or actually, what's the word now? Unless it is able to fulfill the conditions in the locking script, that transaction will not be relayed or allowed through the system. So this is typically how the stack works. Can you guys see this slide? Okay, it might be, I'm going to read it out. So this is a typical script. 2, 3, add, 5, equal. If any of you here has done any reverse Polish notation, you would understand this kind of a script. And generally, when you have 2, 3, and then add, what is happening is that 2 gets inserted into the stack, 3 then gets added into the stack. Then you now have an operation, add, that adds the 2 operands that are already in the stack and then returns the output of that operation back into the stack. So what we have here is that we have 2, and then we recognize that is an operand. Then we have 3, and we recognize that is an operand as well, so it gets pushed into the stack. Then we have add, which now adds those 2 items and then pushes the result into the stack. Then we now have 5. So what happens is that the result from that operation, 5, is in the stack, and then we've now added another item again on the stack with the number 5. And then we have another operation called equal that compares the 2 items or the last 2 items on the stack. Now, 5 equals 5. What's the outcome of that? Is that true or false? It's true. And so, for that particular script, the end result will be true. And then that transaction is allowed to go through. But if, for instance, we had something like 2, 3, add, 4, equal, that script will never evaluate to true. And so this is how the scripting system typically, you know, is able to evaluate conditions and know, okay, the conditions have been fulfilled, and so this transaction will be allowed to go through. So I'm going to, because I have very limited time, I'm going to switch very quickly into our demo session here. And I am going to attempt to, I'm going to run. All right, so I am running the Bitcoin server, and I'm just going to leave this running in this particular screen. And then I'm going to generate a couple of blocks. Before we do that, let us look at this particular script here. So I'm using a Python library called Python Bitcoin Tools. It's written by one of the core developers, or one of the reference implementation programmers for Bitcoin, called Peter Todd. And some of this stuff are going to look like gibberish, but bear with me here. What I'm trying to do is just kind of create, show the process on how we create receiving addresses, how we create transactions, how we sign transactions, and some of those little concepts. So here I have two people called Alice and Bob, and I have created keys for them. And in the Bitcoin system, what we generally use as keys are just very, very large random numbers. And so those random numbers will be very secret. These are not things you're going to share with anyone. And that is how we would, whenever we're trying to create a signature, we would use those numbers to sign, those transactions and what have you. So I have two people here, Alice and Bob, and all I've just done really is, I have pre-created some secret large numbers, and then I am trying to create a Bitcoin address for both of these. And so I can run this. I can run this script, and it will tell me what the Bitcoin addresses for Alice and Bob are. And with these Bitcoin addresses, I can now send payments to them. Now, these Bitcoin addresses are a representation of their secret keys. But we have this very interesting situation where I can only derive an address. I can derive an address from a key, but I cannot derive a key from an address. Does that make sense? So that means I can share my address, my Bitcoin address with you, but you wouldn't know what my secret number is or what my secret key is. I'm going to give Alice some coins. Right. So I have actually just run a script that has created some transactions and has assigned some coins to Alice. Okay, and I can list unspent transactions, and I can see that here for this particular transaction, which has the transaction ID of F39C082 blah blah blah, that this address has 25 bitcoins, which you can see here from the amount. So I have given Alice a couple of bitcoins, and so generally what that means is that Alice can now create a transaction spending any of those bitcoins and sending it to Bob. But I'm not going to do that. Let's go a little bit into something more exotic. So I showed you this script where I just basically generated some secret keys, and then I created a Bitcoin address for Alice and Bob. So typically, if I was going to create a transaction, I would first of all start by, getting Alice's private key or her secret key. Then I will create a transaction. And the way I create this transaction is to specify a series of inputs and outputs. Here I have an input where I'm specifying the transaction ID, a certain transaction ID, and then I'm specifying the index that I want to spend. And then I also have an output where I am saying I want this point to go to Bob. And then once I'm able to create that transaction, I then sign that transaction. And here you see Alice signing the transaction. And then the transaction is output to the terminal, and then I can copy that particular transaction and broadcast it. And when I broadcast it, as long as it is valid, the network would accept it, and Bob will have those bitcoins. Now, this is just a very simple transaction. It's the typical transaction we all do from day in, day out, where I just want to send funds to my friend's bank account. But things can get really, really interesting, and I'm gonna stop here by explaining one of such really interesting applications. Take for example, we run an organization, and one of the things that we want to do in the organization is that we want to require that at least 2 of the directors of that company sign the transaction before that transaction ever gets valid. Now, the company could have 5 directors, but we only need 2 of them to sign, any 2 of them to sign. Now, if you start to think about the ramifications or the implications of how you can implement that, you can start to see that you can create very, very powerful accountability in how companies are run. So you don't have a situation whereby, one of the directors, because he had access to the bank account, is able to go to the bank and, basically write a check to himself and run away with the funds. And I know that in the banking system, we also have something similar to this, where you have mandates that require maybe at least two of those directors to sign before, they honor any transaction from that account. But we also can do the same thing here as well. And so a typical transaction for this type will be called a multi-signatory or a multi-sig transaction. And basically all we do in the scripting system is say that I have M number of public keys. And out of this M number of public keys, I have N, or any N can sign to create a transaction. And here I actually have a very interesting script here where I've said I have 2 public keys, Alice and Bob. But I want it in such a way that before funds are released from this address, the 2 of them must sign. Now what that means is that even if Alice tries to sign a transaction by herself, that transaction will not be valid. It requires that the 2 of them sign before funds can be moved from that address. And in this particular example, very similar to what we have for a typical Bitcoin address, we also just have an address as well. So I can give you any Bitcoin address and say, send the funds to this address. And you may not know exactly all the very exotic kind of conditions that are put in order for the people who own that address to be able to release funds from it. Now, there are so many other kinds of applications or different kinds of scripts that we can create to do different kinds of interesting things. One of them could be, a no questions asked money back guarantee. We all, some of us actually know about e-commerce and how we do e-commerce in Nigeria. We have this system called pay on delivery, where you can make an order online, and when it gets delivered, that is when you make a payment. But there are a number of problems with that system. One problem is the fact that as a merchant, if I have other competitors, I can have a customer make a purchase across maybe 3 different merchants and say, first to deliver. And so maybe I am the unlucky one and I came after my competitor has delivered. Remember, I've spent money actually trying to get this product to the person, and the person comes and says, "Oh, I'm sorry, I already got the item from this other merchant, and as a result, I have to basically take the loss of doing that delivery." What if we had a system whereby the merchant could actually be guaranteed payment if they do a delivery on time? If the seller actually delivers on time, they will get the funds. And if they don't, the buyer doesn't have to, complain to some other third party or some other person to it wasn't delivered on time, I want my money back. They can actually get their funds back. And we can actually do that today using Bitcoin. I already talked about multi-sig. And we could also do time lock transactions where I could say this payment is only valid on December 25th and beyond. We can create a lot of different kinds of really interesting scenarios where you have to fulfill interesting situations before funds can be unlocked. There are still many other applications that hopefully maybe you guys will be able to come up with. You might think of some other application. You might look at the scripting system and create your own script and say, I want to be able to do transactions like this. And the system would allow you to do it. So thank you very much for listening to my talk, and this is to your success. Thank you.